Hello students, welcome to eGrew Learning. So today in this lecture we will talk about the logarithmic functions as well as the exponential function, and we will start with exponential functions first. Okay, then we will discuss the graph of the exponential functions and then we will move to the logarithmic functions. There we will talk about what is logarithmic function, the properties of the logarithmic functions and the graph of the logarithmic functions. And then after completing exponential function and logarithmic function, we will discuss some important question from JEE Advance point of view on exponential and as well as logarithmic functions. Okay, so let us start and see what are exponential functions. So talking about exponential functions, a function is of the form y equals to a to the power x. If I give you y is equals to a to the power x, मतलब ऐसे जितने भी टाइप के फंक्शंस होंगे हमारे पास जिसमें we have y is equals to a to the power x, ऐसे टाइप के फंक्शंस को हम क्या बोलते हैं? एक्सपोनेंशियल फंक्शंस. एंड देयर आर सर्टेन कंडीशंस ओवर इट दैट इनके ऊपर कुछ कंडीशंस भी हैं, जैसे a should be first positive, it cannot be negative, and the second thing, this cannot be equals to 1. means अगर a 1 हो गया, so 1 to the power x, so that will always remains 1. So there is no point talking about the exponential function in case a will be equals to 1. And we also know that a should be positive, so negative का power हमें नहीं चेक करना, ठीक है? a हमेशा positive होना चाहिए और a equals to 1 नहीं होना चाहिए. Okay, so this is the y equals to a power x is what we call it as exponential function. Now let us see the graph of this exponential function. अब देखते हैं कि ग्राफ कैसा होता है. x की वैल्यूज इंक्रीज करने पे ग्राफ इंक्रीज होता है या x की वैल्यू डिक्रीज करने पे ग्राफ डिक्रीज होता है. Now let us see that. Okay, this is my x-axis, this is y-axis. Okay, and we are seeing that this is x-axis. Now if I'll say when x will be negative, so the graph of a to the power x goes like this, where this point is 1. So this is the region where x is negative because this is origin, and this is the region where x is positive. That means ये वो वाले सारे regions है जिसमें x positive है. x positive है तो ग्राफ का वैल्यू क्या? x negative है यहाँ पर. x negative है तो ग्राफ का वैल्यू 0 से 1 के बीच में आएगा. ओके, और अगर x positive हो गया तो ग्राफ का वैल्यू बढ़ जाएगा. So this is the case when a is greater than 1. ये ग्राफ तभी बनेगा जब a greater than 1 है. Okay, now we will see the case when a is lying between 0 to 1. So when a is lying between 0 to 1, the graph would be like this. This is the case when a is lying between 0 to 1. अब ये वो वाला केस है जहां पर a हमारा 0 से 1 के बीच में लाइक कर रहा है. ओके, दैट मीन्स अब इसका ग्राफ देखेंगे. लेट सपोज अगर मुझे हाफ टू द पावर x का ग्राफ देखना है तो हाफ टू द पावर x का ग्राफ ऐसे ही जाएगा. ओके, 1/4 टू द पावर x का ग्राफ भी ऐसे ही जाएगा. सो वी विल कंपेयर इट कि ये ग्राफ्स कैसे जाने वाले हैं, एंड वी विल ऑल्सो सी द ग्राफ ऑफ 2 पावर x, 4 पावर x, 6 पावर x, ये ग्राफ कैसे इंक्रीज करेंगे. ओके, सो दिस इज द बेसिक ग्राफ ऑफ y इक्वल्स टू a टू द पावर x, where a is greater than 1. we will consider this graph. when a is between 0 to 1, जब a 0 से 1 के बीच में, हम ये वाला ग्राफ नोटिस करेंगे. okay, now we'll consider or we will discuss the different graphs depending upon the values of a. That means when a is 1, we will see the graph. When a is 2, when a is 3, 4, 5, like this. A cannot be equals to 1, so we will not take the case when a is equals to 1. Okay, सो लेट अस टॉक अबाउट, अब बात कर लेते हैं डिफरेंट केसेस की, ए की। ओके, पहले हमारा पॉइंट 1 को फिक्स कर लेते हैं। यस, एक हाइपोथेटिकल लाइन बना लेते हैं हम यहाँ पे। नाउ लेट्स सपोज दिस इज द ग्राफ ऑफ y इक्वल्स टू 2 पावर x। अब y इक्वल्स टू 4 पावर x का ग्राफ इससे ऊपर जाएगा या इससे नीचे जाएगा, दैट वी नीड टू टॉक। ओके, सो y इक्वल्स टू 4 पावर x का ग्राफ अगर मैं देखूं यहाँ पे तो नीचे रहेगा, बट यहाँ पे ये ऊपर हो जाएगा। सो लेट्स से दिस इज y इक्वल्स टू 4 पावर x, एंड सिमिलरली इफ आई ड्रॉ द ग्राफ ऑफ y इक्वल्स टू लेट्स से 6 पावर x, सो ये ग्राफ यहाँ तो नीचे रहने वाला है, यहाँ पे जाके ऊपर हो जाने वाला है। सो दिस इज y इक्वल्स टू 6 पावर x। सो अगर अब हम a का वैल्यू बढ़ाते जाएंगे तो इस रीजन में y का वैल्यू जल्दी बढ़ने लग जाएगा एज कंपेयर टू जैसे जैसे x का वैल्यू बढ़ेगा। ओके, एंड इन दिस रीजन y का वैल्यू नीचे रहेगा जब x का वैल्यू छोटा होता जाएगा। Okay, so this was the case when a is 2, 4, 6. Now let us consider the case when a is half 1 by 4. Okay, when let's say a is 1 by 4, we can say that the graph will be like this. This is y equals to 1 by 4 to the power x, and अब अगर हमें देखना है y equals to 1 by 2 to the power x का ग्राफ, तो ये ग्राफ इधर नीचे रहेगा और यहाँ पे ये ऐसे रहेगा। सो दिस इज द ग्राफ ऑफ y इक्वल्स टू 1 by 2 to the power x. So this is how we can compare the different graphs basis on the values of a. Okay, now let us talk about the domain of this function. What is the domain of the function? You know that the domain क्या होता है? x की वो values जो function इनपुट में ले सकता है। yes, the values of the x or the values of the input that the function can take. Yes, here you can see that we can draw the graph of the function throughout all the values. That means the domain of the function is r. What about the range of the function? Now अब function का range क्या है? The range of the function is 0 to infinity, and 0 is also not included. So that is, we can write this as 0 to infinity. Okay, so this is about the domain and range of exponential functions. Now let us talk about the logarithmic functions. Now we will see the graph of logarithmic function, and then we will talk about the properties of logarithmic functions. Okay, so पहले बात कर लेते हैं what are the logarithmic functions. So logarithm is a scale where we compare different values. Means let's say if I am writing y is equals to log of x to the base a, this is what we call it as number. इसको हम नंबर बोलते हैं लोगेरिथम में। दिस इज द बेस ऑफ द लोगेरिथम। किस स्केल पे वी आर मेजरिंग दिस नंबर, ओके, एंड देयर आर सर्टेन कंडीशंस ओवर इट। यहाँ पे कुछ कंडीशंस भी हैं, लाइक a शुड बी पॉजिटिव एंड a शुड नॉट बी इक्वल्स टू 1, एज वेल एज x शुड बी पॉजिटिव. So these are the three necessary conditions for the logarithm to get defined. Okay, so if we already know that x is positive, that means the domain of this function is from 0 to infinity. That means the domain of this function is 0 to infinity. Now talking about the range, we will see from the graph itself. Okay, x, y. Okay, if my a is greater than 1, means the base of the logarithm is greater than 1, so the graph of the logarithm will be like this. Y is equals to log x to the base a in the case when a is greater than 1. Okay, now the graph of logarithm of x to the base a would be like this. This is y equals to log x to the base a. Here a is lying between 0 to 1. Okay, so this we can see that this is an increasing graph. मीन्स जैसे जैसे x का वैल्यू बढ़ता जा रहा है वैसे वैसे y का वैल्यू भी इंक्रीज होता जा रहा है. एंड हेयर यू कैन सी दैट इन दिस ग्राफ दिस इज अ डिक्रीजिंग फंक्शन. डिक्रीजिंग फंक्शन मीन्स जैसे जैसे हमारा x का वैल्यू बढ़ रहा है y का वैल्यू डिक्रीज हो रहा है. सो दिस इज ए डिक्रीजिंग फंक्शन ग्राफ. ओके, नाउ इफ आई टॉक अबाउट this increasing function graph when a is greater than 1. So we will compare the different values of the graph also. Let's suppose if x is 2, or let's say if base is 2, 3, 4, 5, 6. First we will increase the base, then we will see the impact on the graph, and then we will decrease the base. Okay. So now let's consider the different values of e. Okay. And let's say if this is y is equals to log x to the base 2, then this will be, let's say, y is equals to log 4 base x. Okay, and similarly we can plot the other graphs. So if we'll increase the value of the base, the graph will decrease like this. Okay, that means lower the base, higher up the graph would be. Okay, lower the base, up the graph would be. And now if I'll talk about the properties based on logarithm function. Now let us see the properties of the logarithmic functions. And before talking about the properties of the logarithmic functions, let us first write the domain and range of these functions. So as you can see that domain of this function is, we have already written here that domain is 0 to infinity, and the range, as you can see that the graph was going from negative infinity to positive infinity. That means all the real values the graph can take. Okay, so these are about the domain and range of logarithmic function. Now let us talk about the properties of logarithmic function. So talking about the properties of logarithmic function, okay, so the first property that we have is, पहला property ये है, log of xy to the base a is log x to the base a plus log y to the base a. That means keeping the base same, we can add the two logarithms. Okay, let's take one example. If I have log of 6 to the base, let's say some variable a, so this would be log of 2 to the base a plus log of 3 to the base a. Okay, now second property is for division, log of a x by y, that is log of x to the base a minus log of y to the base a. Okay, this is the same property, just we have x upon y here, so this there will be a negative sign. Now let us talk about the third property we have in logarithms is log of a to the base, a is the base and x to the power b, that would be b log x to the base a. लोगेरिथम में नंबर का जितना पावर होता है ना वो पावर आगे आ जाता है. So this power will come forward and the logarithm will remain as it is. Okay, now the fourth property that we have here is power of base as well. So this is x to the base a, x to the power a, x is the base and whose power is a, y is the number whose power is b. So this property is b upon a log y to the base x. ओके क्या है इसमें, नंबर का पावर तो हमें ऑलरेडी पता है कि वो आगे आ जाता है, और जो बेस का पावर है वो डिनोमिनेटर में चला जाता है. ओके दैट इज b अपॉन a log of y to the base x. So this was the fourth property. Now let us talk about the fifth property that we have is, let's say if we are given log of a to x to the base a is greater than log of y to the base a. So we will write this will have two cases. X will be greater than y when the number or the base we are saying is greater than 1. Okay, and when the base is lying between 0 to 1, we can say that x will be lesser than y. That means the sign of the inequality will get changed. ये कैसे समझ में आएगा? अब देखो, when a is greater than 1, we have seen the graph of the logarithm when a was greater than 1. Okay, so when a is greater than 1, we know that this is an increasing function graph. So if this is an increasing function graph, the sign of the inequality will not change. Means higher the value of the input, higher the value of the output would be. Higher will be the input, higher would be the output. Yes or no? Okay, now but in this case, when a is lying between 0 to 1, we know that the graph looks like this. Okay, so this is a decreasing function. Higher the input, lesser is the output. So higher the input, lesser is the output. See, you can see that this is an input for this function. So if we'll say that lower is the output, higher will be the input, you can also change the statement like this: lower is the output, higher is the input, or higher is the input, higher is the output, lower is the input. Okay, so you can follow the same statement. That means this is a decreasing function. So in this case, if this is a decreasing function, then log of x to the base a, if it is greater than log of y to the base a, so we can say that x would be lesser than y in this case, and x would be greater than y when a is or base is greater than 1. Okay, so this was the fifth property on logarithm. Now let us talk about some more properties. So we have the sixth property is log of x to the base a. Now we can also write this as log of some other base x upon log of a to the base 10. So here base should be same. We can also write this as base 2 base 2. That means you can split this number, logarithm of the number to the some different base upon logarithm of the base to some different other base now. Okay, so this is the sixth property. Now the seventh one is, if we have log of, okay, so what we can do is we can interchange these number and this base, so that would also become log of e to the base x. Okay, that means this number e and this number a will get interchanged between each other. Okay, now the eighth property is log of b to the base a is 1 upon log of a to the base b. Okay, using this property we can also denote this. Log of b to the base a is 1 upon log of a to the base b. So this was about the properties based on logarithms. This is an important property. Kindly do remember this, okay, because we will face some of the questions based on inequalities in logarithms also. Okay, now let us talk about the questions. So the very first question that we have here is, if we are given the function as under the root log of base is 3 cos of sine of x. Okay, and I need to find out the domain and range of this function. So how to get the domain and range of this function? So we already know that the function that is inside the square root should always be positive. That means what we will equate here is log of 3 cos of sine x should always be greater than or equal 0. So I can say that from here cos of sine x would be greater than equals 3 to the power 0, because we know this property that log of x to the base a, if it is equals to y, then x is equals to a to the power y. This is the very basic property of logarithm. That means, and if we know that the base is greater than 1, so there won't be any change in the sign of the inequality. Yes, so cos of sine of x would be greater than equals 3 to the power 0. That means cos of sine of x would be greater than equals 1. But we already know that, and we have already seen the trigonometric functions. We know that the range of the cosine functions cannot be greater than equal 1. Yes, so it should be greater than, or it should be equals to 1 only. So cos of sine x should be equals to 1. So if cos of sine x is equals to 1, we can say that sine x should be equals to either, this is, we know that the graph of cos of input. So cos is 0 when sine x will be either, cos will be 1 when sine x will be like 0, this as 2 pi, like this. Okay, so the input inside the cos should be sine x. I can say that sine x should be equals to 0 or 2 pi. So from here x, I can say that x will be equals to n pi, where n belongs to integer. Means when sine x would be equals to 0, cos 0 will be equals to 1, and sine x is 0 when x is equals to n pi, where n is an integer. That means this is the domain of the function. Now talking about the range, so we know that cos of sine x hardly can take the value equals to 1. That means this value will not be greater than 1, but it will be equals to 1 only. That means this will be 1 when the number inside the logarithm is 1, the value of the logarithm will become equals to 0. Hence the range would have, रेंज में सिर्फ एक ही एलिमेंट होगा ना, कैसे एक ही एलिमेंट होगा, अब इसका पूरे का वैल्यू 1 है, सो वी नो दैट log ऑफ 1 to the base 3, इसका वैल्यू 0 हो जाएगा, तो इसका वैल्यू 0, दैट मीन्स रेंज विल हैव ओनली वन एलिमेंट दैट इज 0, and the domain will have elements n pi, where n is an integer value. Okay, so this was the very first question that we have discussed based on logarithmic function. Now let us talk about some more questions. Okay, so let's say if we have the question like log of base x and the number is x square minus 1, this is greater than equals 0. Okay, so or let's say if this is given to us as lesser than equals to 0. Let's make some interesting question here. Let's say if this is given to us as lesser than equals to 0, we need to solve for x in this. So how to solve for x? First I should take care, or let's say consider the case, make some cases. Case 1 here, when my base is greater than 1. So when the base is greater than 1, we know the graph of the logarithm, it should be an increasing function graph. So the output should be lesser than 0. Output here is lesser than 0. When the output is lesser than 0, the input is between 0 to 1. So I can say that x square minus 1 should lie between 0 to 1, and hence we can say that x square should lie between 1 to 2, and x should lie between either 1 to root 2 or x should lie between minus root 2 to minus 1. Okay, so but we have already considered x to be greater than 1, so the answer from this case we are getting is 1 to root 2. Okay, now consider the second case when base is lying between 0 to 1. So when base is lying between 0 to 1, my graph of the function would look like this. Yes, so when base is in between 0 to 1 and the value of the function should be lesser than 0, so the graph should be here, so the input should be greater than 1. I can say that in this case x square minus 1 should be greater than 1 in this case, and hence x square should be greater than 2. If x square will be greater than 2, I can say that x will be either greater than root 2 and or x will be lesser than minus root 2. Okay, but we have taken x to be in between 0 to 1. So we can say that from this case we are getting no solution. क्योंकि हमने ऑलरेडी x को 0 से 1 के बीच में लिया हुआ है और हमारे सॉल्यूशंस आ रहे हैं x is greater than root 2 and x is lesser than minus root 2. So we can say that we will not get any solution. So the final answer to this question would be this only, 1 to root 2. So x belongs to 1 to root 2, both open. So the answer to this question will be this. So I hope students now you are pretty clear about what are the exponential functions, what are the logarithmic functions, and how to solve the questions based on exponential as well as the logarithmic functions. I hope you will like my video, and if you like my video, kindly do subscribe my channel and share the channel as much as possible. Thank you.